Welcome back. Now we're turning on loops. So we already learned how to use lists and arrays, right? Let's assume we want to print from a list all values one after each other. We could do that by writing, if there's 100 numbers, 100 print lines. Or we could use some automated setup where we go into a list, taking our first value, do something, then iterating to the next value, do something, iterating to the third value, do something. Since every time we want to print, we could just use every time the same um, function, the same process, print x, and x is just the current element of our list. If we have such a case, it seems like an iterative process where we do the same thing over and over and over again. We can make our lives much easier writing one loop, doing this for us instead of writing 100, 200, 300 lines of code, depending on the setup, what we want to achieve. This is called a loop because it loops through something so it starts something, do something, and then it loops back to the beginning and does the process from the beginning, what we've written again, till the end, then goes back to the start, back, and so on. So it's a loop, a perfect circle, so to say, and doing it over and over again until a condition is met and the loop stops because something is met and we can stop doing what we're doing right now. And loop are very useful so if we have an operation which we have to do multiple times until some condition is met. For example, we want to look at how many things fit into a bigger thing. So we count and count and count until we reach a threshold that there's no space left. Um, and there are several ways and several occasions where we really can use loops in a helpful manner, and our lives are easier. It's kind of hard to explain when you should apply it and when not, but the longer you face problems where loops could help or not and do programming stuff, the more natural it feels when you have to use a loop or not. Um, but first of all, we need to learn how loops function. And basically, there exist different loops. For example, while loops, for loops. Those are the both two most common loop types. And most of the times they're used for looping through three main applications, three types of things. Um, Most of the time, we can divide this while and for loops into that we have a counter, a number which facilitates as a counter, and we count our steps. So we want to do something 2 times, 3 times, 10 times, whatever, many times. Or we have something like a list, which we already learned, and we want to go through that list and maybe inside that list through another list. So we have lists, and we do this until the list is empty. So the list contains all the values which we need to work through, and we do this until we we worked through all the items in that list. Or, for example, if we do natural language processing, so speech, text to speech, and stuff like that, we need words, and then we need to transcribe them. So we need to go um, symbol to symbol through a word. So we want to loop through a string, for example, hello world. So we want to have an H, then an E, then an L, then an L, then an O, then a space, then a W O R L D, and we want to loop through such strings. So those are the three main applications. Now, to learn how loops function, I would just suggest that we do a while and a for loop for each of those occasions. And let's start with a while loop so we get the feeling how they work, and a number counter because that's most of the times the most straightforward and easiest to imagine in your head. So what we now want to do is a while loop with a number counter. Right? Okay. So when we do such loops and use a counter, we usually, in most programming language, need a variable where the counter is initiated with, and this variable holds the current counter. So for example, we did variable, most of the time we call it I, and this equals 1 in the beginning. So currently we're at step 1, and we want to do this until this variable I reaches a certain value. So we want to loop through as long as, this is called while in a while loop, while the variable I is below or below equal, let's say below a certain value. Let's make this value a 6. So as long as I is lower than 6, we continue our loop. Once that threshold is reached, we stop it and do no more looping. Okay, then with a double point, we start the loop, and everything which is now again with some spacebars in front, as you can see here, is part of the loop. So now, as long as I is below 6, we do everything of the commands which will follow now. Okay, and for example, we could say print something, so we see directly the result. And let's say we print while output counter, and while output counter, and now let's give us the output counter. So we need a string again because we need same. Oh, I forgot the plus. So first of all we need plus string of the counter I, and then make another string is below 6. This is shown. So this basically tells us now for each step of the loop the current counter, and we can check if it actually does this until it reaches, as long as it is below 6. Once it reaches 6, this output shouldn't be given anymore because then the condition isn't met. It's like an if-else condition. Okay, if condition is met, do this, else not. Basically, if we do this round by round by round in a loop, that's called a loop. So, but now what happens if we would do this now? It should go on and on and on and on. We could try this for a second. If I hit play now, well, because what happens? I equals 1. Is I below 6? Yes, so do this. And then in the next step, is I still below 6? Yes. Is it still below 6? Yes, because I isn't changed at all. If we now hit play, we should exactly have an endless loop, always printing 1 is below 6, 1 is below 6, 1 is below 6, because it isn't changed. Until we hit the stop button. Great, that worked. And now we have a long list where it loops for an infinite time. Sorry. As you can see, the output is huge. So I'm going outside, and we have to change that. Somehow, I has to reach 2, has to reach 3, and so on. So it actually, at one point, stops the loop when reaching 6. Therefore, we need to add to I 1. So what we do is I equals I plus 1. So we take the current value of I, add 1 to it, and say this is the new variable I. So in the beginning it's 1, then we add 1 to it, so it's 2. Then we go in the loop, is 2 smaller than 6? Yes. Okay, then 2 plus 1 is 3, and say this is now I. Is 3 smaller than 6? And so on. Programmers are again lazy people. In Java, for example, you can just write I++ to achieve the same command as I just typed here. And in Python, you usually write plus equals. And that means plus equals 1. That means that you directly tell I equals I plus 1. It's the same command, and you basically achieve not typing 2 buttons. But programmers are lazy. So as you know it, this is the same as I equals I plus 1. And we do that. Now it should work. Let's run it again. Okay, 1 is below 6, 2 is below 6, 3 is below 6, 4 is below 6, 5 is below 6. Then I is 6. While condition isn't met, stop the loop. This is basically how loops work. Now let's do the same with a for loop. We have to go out to the full left and make our for loop with a number counter. So the thing is, for loops in Python work with something you already know, the range function. So we need the range function again, and as a reminder, the range function works that the first value is the start value, then we have the end value, and then we have the step value. So how big the steps are. Is it 1 step, a 2 step, a 3 step? If it's 1 step, we can leave it blank. We don't need to type it because default wise it's a 1 step. So for the for loop, we have to write for. Now we need a variable as well. We could call it I, we could call it X, we could call it Y, whatever we want. Let's call it X. This is our variable. And as long as X is in a certain range, this is how it works. So for X is in the range of, sorry, not range I want to type, range of 1 to 6. This should be the same range. And the step we want to 1, we can type it or we can leave it blank. It's the same. For completeness' sake, I'm writing it. Okay? So as long as, so this is basically the same. This is a variable and we say it's 1 in the beginning, and as long as it is not 6, it's the same as here, everything's okay. And the step plus equals 1 is standing here. If you would write a step of 2, then it would be the same if here would standing 2 as well. You get the idea. And now again, double point to start. Everything following now is part of the loop. And what we want to do is, we want to basically put out the same output as here, with the difference. This is now the for output, and the counter is X. And let's look at the result. For output counter, 1 is below 6, 2 is below 6, 3 is below 6, and 5 is below 6 in the last step, and the 6 isn't again. So we've basically built the 2 identical outputs. We have the identical loops, one built with a while loop, one with a for loop. Okay? So oftentimes in Python, if you have a counter variable, the while loop is used because you do that while the threshold is met. And if you have lists, usually the for loop is more often used. But some people prefer the for loop, some prefer the while loop. It kind of is built up oftentimes of what you learn first, what you do more, and then you feel comfortable with it. You know the syntax in your head, and the other one you need to look up. So you stick with the one you're most familiar with, oftentimes. There's certain advantages for each of those, but it doesn't matter right now. You can see you can most of the times achieve with both loops the same things. Okay, this was nice. Now we have the numbers counter done. Now we go through lists. So what we do want to do now, we currently have a for loop. So let's stick with the for loop. So for loop for a list. Okay, so first of all, we need a list. So let's make a new variable called loop list, and this list, what should it contain? Well, let's get a bit crazy again. Let's make one apple. Then let's make, oh, by the way, now I have not those quotation marks. Now I have only the single quotation mark. In Python syntax, it doesn't matter which one you use, as long as you use quotation, whichever you use, it works as a string. Or yeah, as a string. And let's start with apple, then we have 1, then we have 2, then we have a banana, because I'm feeling like fruit today. So this is our loop list, which we will use. And now we need our for loop. So again, for x is in, and now we need the list. Before we used range, now we can just use the list directly. So as long as it is in loop list. So what does this do now? If I just give it a list. The for loop now goes into this list, which I give it to him, and says, okay, there's an element, so let's start with that. Then we go to the next element, then we go to the next element, then we go to the next element. And we say, as long as it's in loop list, it tries to go to the next element, finds the list hasn't got a next element, so we're out of the range of the list, so let's stop the loop. So it basically goes one time, element by element through the list, if we give it a list, this for loop. So we can check that by just printing the current value of the list, which is the current value of the list. As before, whatever we say for x is in the loop. So the first element of the loop list will be given to x, and then we can use this x to manipulate or print or whatever with the current element. It was the same as before, because we said as long as x is in the range of 1 to 6 with steps of 1. So it started with a 1, gave that to x, we printed x, then we say, okay, the next element in this range list will be 2, so we gave the 2 to x, and then we printed 2, and did this until we reached 5, and then the 6 we broke, we stopped the loop. So we're doing the same here, so we can just print x, and now there should be apple, then 1, then 2, and then banana. See the old outputs, and now let's check apple, 1, 2, and banana. Okay? So x will get the value of the first element, then in the next loop iteration it gets the second element, in the next loop iteration you get the third element, in the next loop iteration it gets the fourth element. Can we do that with a while loop as well? So while loop for a list. Well, sure. First of all, we need our loop list again. So we do not need to declare that again necessarily, because loop list already exists, but for the sakeness of completeness, we do this. Okay? What we have to, so we could use this code as a snippet and copy it somewhere else and it still would work. But what we have to say here is they are not so ideal, because at least in my perspective, for loops are much better for lists. This is one of these occasions where I don't like it, because how do while loops work? So first of all, a while loop has a counter and an end value, and this is always true. So to know when to stop the while loop, you need to know the end value. And the end value is basically, as we know, a loop has elements. We count from 0, and then we count until the end. And since it's 4 elements, so it's 0, 1, 2, 3 is the 4 elements, we need to count till 3. We know this because a loop is 4 elements wide. But if we want to do that so it's interchangeable, the list could have 5 elements, etc., we need to know which integer value is the end of the loop. So the next thing we need to know is what is the end of the list, and we can do this by printing. So we can check if that works, this function, by the function length. So len, for short for length, will give us the length of the list. So by typing length, loop list, and printing that, we should now get in the console the length of the list. You can see the list is 4 elements long. So to make our while loop, we actually still have a counter variable I equals 0 in that case, because we count from 0 in lists and arrays, so we get the first element. Then we say while I is smaller than length of loop list. So what does this do now? What we basically say, we start from the first element, and now we can print loop list element 0, as we already learned for lists. Then we need to go to 1, then we need to go to 2, then we need to go to 3, and then it should stop, because we have 4 elements. So as long as I is smaller than 4, this is exactly the length of the list. So now we can do a print again. And we can print basically loop list element at position 1, because it starts at 0. Then it should go to 1, 2, and 3, and by 4 it stops because of that condition. And we then need to iterate I plus 1. And now this should have the same output as here. So after the 4 exactly, which is now dividing those two loops, apple 1, 2, banana was the for loop, and apple 1, 2 is the while loop. And as you can see, this is just not so convenient. I still need a counter, I need this new variable, while here it's 2 lines of code. I have here those lines of code. So for lists, for loops are much more convenient. But still, you can achieve the same result with a while loop. Okay, now that we achieved this, let's do the last most obvious thing, or from the top here, the most often application is natural language processing, so looping through a string. So just stick with a for loop here, okay, for loop for strings, and we don't look at a while loop, because that's again a bit unnecessary now, or more inconvenient. So first of all, we need a variable with a string, which we call loop string. And what are we looping through? Which string? Let's call it just string. Okay. How do we achieve this? Again, we have 4x. We now know that, and this has to be somewhere in. And where is it in now? In a string. In which string? We called it loop string. It's nothing more than that in Python. And what do we want to print? Each letter which it looped through. So we just print x. And now we should have a J, a U, an S, a T, a minus, a big A minus, a big S, T, R, I, N, G. That should be the output. Just a string. Works fine. So one last thing before I get to the exercise, or I'll give you your exercise. Sometimes we have special occasions. Sometimes we have to stop a loop. And this is quite often the case if you program big functions, programs, stuff like that. It's not so necessary to get the idea of functions, but it's something which occurs in reality quite often. So sometimes we have to stop a function or a loop when something happens, okay? Or is found. For example, you sort something, you have a certain value, you search for, I don't know, you search for a search term within a document. Once you got it, you stop and show the result to the user and stuff like that. So you only search until you find it, then you stop it. You do not have to search the full document, etc. Such stuff happens, and therefore we have a condition which we can put in a loop or a function, and then it's just killed stop it, do not process any further because processing time is valuable time. You can do something else if you stop it early. So this thing we use here for, therefore the break is invented. We call break. And let's look at it. So how does it work? So let's take first of all a for loop for x in range whatever. Sorry, range 0 to 100, let's say. And what do we do here? We print x. So we see at which iteration we are in our loop, if we're at 50, 60, or whatever. And let's make it really, really easy, okay? Let's just say if we found the 10. So if x equals 10, then we're just done. And then we just type break. Only the single line of code break will force a loop or a function to stop immediately. That basically means kill all processes, you're done. Shut down, so to say. And now let's look at it. As you can see, oh, sorry, why it doesn't exist, but still, these are no hard loops. It's still really fast in the computation. So after just a string, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it stops. If we ignore the break, it should print all numbers till 100. Okay, now you're saying I need a command. Print x again. So we print x 2 times. And now it goes to 100. Once the break is here, it immediately stops once it hits the break at 10. Great. So with all this about loops, you should be now able to start working on your own loops. So here's an exercise. Just make a loops, okay? A while or a for loop, whatever you want to. And this loop should only plot odd numbers between 0 and 100. So odd numbers are a 1 and a 3, while even numbers, for example, is a 2 and a 4. Okay? Because we start at 0, we have to know if 0 is an odd or an even number. For our case, we say 0 is an even number. I think officially it's defined as this. Sometimes it's defined as not both. Sometimes it's defined as an odd number. But in our case, as most of the times, it shall be an even number. Okay. And after you've done your preferred loop, try the other one as well. So I want this once done in a while loop, and I want this once done in a for loop. Odd numbers between 0 and 100, even numbers not printed. Have fun. I show you the solution in the next video.